Hello everyone, my name is Parthiban. I am part of Linumiz, the company which does embedded software servicing. Today, we are going to see an exciting demo in part of our open source collaboration and activities, which is involving Zephyr and as well as NuttX real-time operating systems, and both of them running in an open source stack with a custom applications built on top of it. What we're going to see, I will explain in detail about this, and then we also have a follow-up demonstration in live with real actions running both hardwares running on Zephyr and as well as Zephyr NuttX real-time operating system. So I would start off with some basic introduction about what is Linumiz. Linumiz by itself is an embedded software servicing company, primarily focuses in the field of BSP, driver development and core low-level development areas in the field of embedded Linux and as well as real-time operating system. Linumiz, as the name suggests, Linux plus customization, which involves initial days with Linux customizations and board bring-ups and BSP developments, and we later extended our portfolio with respect to real-time operating system. We primarily started with Zephyr, and also we are supporting in terms of NuttX and as well as free RTOS in our portfolio of customers. And we also have a couple of other portfolios, which is functional safety and as well as device security. With respect to cyber security, Cyber Resilience Act, we have a team of experts who dedicatedly speaks security in a nutshell, and also we have a strong potential in terms of developing functional safety when it comes to automotive standards like ISO 26262 or respective medical standards as well. So in here, as part of our collaboration between Linumiz and as well as Infineon, the automotive company, where we have the partnership to enable the open source software stack in their microcontroller series of platforms, technically involving TriCore AURIX and as well as TriView platforms to enable open source software stack in the open source ecosystems like Zephyr, free RTOS and as well as NuttX in this case. So as part of this collaboration, we've been working in enabling couple of hardware series, couple of architecture series to enable open source stack. And as part of this collaboration, we have a set of demonstration which I would like to show you today, as well as demo and as well as explanation towards it. So that's the part of explanation in this whole idea. The demo which I would like to show here is about the unified diagnostic services, UDS in short, involving between two real-time operating system in live and connected with a Linux gateway, which you can call as tester or gateway in a nutshell. In this case, both ECUs, one which runs in NuttX, another one which runs in Zephyr, or the UDS server, which provides set of services where it can technically enumerate in the tester device, which is the diagnostic device in here, as a UDS client. And also you have over the air software update. In this case, the firmware by itself is residing within the gateway, will be sent to the device which is based on Zephyr and as well as NuttX. And in this case, the NuttX and as well as Zephyr will act as the OTA client, and this would act as a OTA server for pushing the software. And all of this happens over two different interfaces. One is CAN and another one is Ethernet stack, which I would explain in a moment. So in this case, you have services implemented in the unified diagnostic services between NuttX and as well as Zephyr, and we use MCUboot, which is the de facto bootloader which comes with Zephyr, and it is the same thing which is also used in NuttX case. So technically, MCUboot is not ported for NuttX in a nutshell. We have some basic porting efforts done, but it is also ported now for the TriCore AURIX family of series. So that's one case. I will now step into the real explanation of the stack, what we have implemented so far. So you have the current highlight, which to differentiate what is implemented by Linumiz and what is as part of the open source community available in the upstream community, which is let's say Zephyr or NuttX in this case, and also what is the hardware which is grayed out here. So as I mentioned, the hardware by itself is TriCore AURIX and specifically third generation of the microcontroller, in this case like TC4D7 SoC. So this comes with Bosch MCAN and also comes with Synopsys DesignWare Ethernet controller as part of the hardware SoC itself. And also we have the D flash, which is the primary flash lives as part of the SoC. So that's the hardware infrastructure. And we have MCUboot, which is the bootloader, If you would like to see more about the over-the-air software update about MCUboot or how the secure booting is done, please refer to my other talks in the open source conference a couple of years back, both on the secure boot and as well as about the over-the-air software update. In here, we have MCUboot ported for both NuttX and as well as Zephyr. And technically, you can assume like you have a one flat region of flash which is partitioned into two different sections. One is slot A and the second one is slot B. And your primary running partition is always slot A, and there would be a secondary partition. When you do wanted to have an update, you would flash this image, which is the next version of the image or updatable image, into the secondary slot, which is slot B, and then trigger OTA, which eventually means swapping between A and B. That's the way MCUboot technically works. You can refer to the open source documentation about how MCUboot works in this case. So otherwise, MCUboot is technically ported for this TriCore RX port and architecture in a nutshell, and that's how we managed to get MCUboot working both for NuttX and as well as Zephyr. And of this, you have Zephyr as a core kernel services and as well as NuttX as a core kernel services, which you have access towards networking, access towards CAN with set of APIs and so on. You can use technically the POSIX standards with NuttX, and you can also use raw CAN API with respect to CAN in Zephyr cases. So we have implemented CAN driver for Bosch MCAN in this case in Zephyr and as well as NuttX. The Gigabit Ethernet, which is from the Synopsys DesignWare controller, which is also implemented both in NuttX and as well as Zephyr, and currently available in the open source community as well. So in this case, both NuttX and as well as Zephyr is capable now with CAN and as well as Ethernet communication. On top, you have the unified stack where you can do socket based operation or raw CAN based operation, or in fact, you have a couple of implementation which you can adapt towards, which is the ISO-TP or the unified diagnostic services over IP, or the unified diagnostic services over the CAN interface. This is implemented by us in a nutshell to enumerate this as an unified diagnostic service server, and this server is custom implemented on top of this ISO-TP or DoIP or UDS services, which is provided as part of this whole open source stack. So in a nutshell, the stack looks like of this kind, and when you communicate from the gateway device, as I mentioned in the previous slide, from the diagnostics tester and to NuttX or Zephyr, basically the UDS client would speak with respective device like NuttX or Zephyr in this case over the respective application which is running in their hardware, and it will enumerate the UDS services. You can speak over the UDS services to achieve reading of various diagnostics parameters like temperature, coolant temperature, or whatever the parameters which is embedded as part of it. As part of this particular demonstration which you're going to see, we have some set of static implementations to enumerate or simulate set of data running in this particular server, both in NuttX case and Zephyr case, which can be technically reached from the gateway device and enumeratable. So that's in a nutshell. And this is about the UDS Unified Diagnostic Server running in both RTOS at the same time with two different hardwares, and then you would be able to speak with them over the stack. And technically about over the software update, in this case which I explained, the gateway device would send the firmware package from the gateway to the respective device over CAN or Ethernet. Both of them would supported right now, and both of them is supported over the UDS services. So right now you can see 34 and 36 as a hex value for where you can send the transfer of request, and then the image transfer would eventually happens. And when you get the new image from the gateway, it would be flashed into the secondary slot of the flash region, and then it would reset, and then MCUboot basically swaps this partition and then starts with the new partition, and then you have a new version of software. So in a nutshell, MCUboot takes care of two things, whereas for verifying the signed image and as well as swapping the image between A and B partition. And in case of how the secondary image comes into the real flash region is basically done using unified diagnostic services in a nutshell. So I would take this same example and say the same demonstration is the stack, and then in the follow-up you will see a clear video about how this is set up and how it is functional in a nutshell. Okay, now here we have a setup which represents unified diagnostic services and as well as over-the-air demo together with a Linux capable diagnostic setup. In here you have three hardwares connected. One is TriCore TC4D7, which is the third generation TriCore RX family of MCU, and the same hardware here. In this case, one hardware runs Zephyr, another one runs NuttX real-time operating system. So here you have a Linux capable gateway, which is also connected with a display over HDMI. So the display is driven by the Linux capable hardware. The connection in this whole setup is we have CAN connected between all three devices, and also Ethernet, which is Gigabit Ethernet in this case, connected with the gateway device. In a nutshell, we are going to see how unified diagnostic services, which is UDS in short, and also over the air update demo works in this whole setup using the open source stack. As in this particular picture of representation, you can see two ECUs connected. One is ECU number 1, which is NuttX, and the second one is ECU 2, which is Zephyr. Both of them running the same exact UDS stack with custom implementation to speak with the diagnoser, which is the gateway in this case. So the whole display application which you see driven from the gateway is developed using Flutter, and that's the diagnostic tester which you see here. So this is touch interactive based demo. So I would start touching this one. This is the front panel which you see, and out of which there is no devices which is discovered or connected, because we need to set up the communication between CAN and as well as Ethernet manually. Right now, this particular network in the gateway over CAN is down. So I'm going to restart or set a specific bitrate. In this case, both of this TC4D7 hardware speaks over 500 kilobits per second. So I set 500 kilobits per second and restart the interface, and then it shows the interface is up, and also the bit rate is 500 kbps. And if I come back and then say discover, you see ECU number 1 and as well as ECU number 2 is discovered over CAN, and this technically discovers over the unified diagnostic service protocol itself or the stack itself. So I would walk through this particular interface of demo, what it happens and what is it happening with this particular UI interface. I can navigate between ECU 1 and ECU 2 by touching in this specific interface here. And here we have control, data, fault detection, and there are a set of routines and as well as console access to be done. Out of which we have over the air software update, which you can select between multiple different versions of software, and these binaries or the signed binaries which is residing within the gateway. I can select various versions and then go and update it. I'm not going to do it now. I will take a moment to explain the remaining part and then come back to the firmware update. In terms of data, there are UDS data specifically hard coded in these two elements, which is going to fetch the identification number, serial number, engine speed, and all of it. For example, if I click read on the engine speed, you see approximately 1000 RPM. If I reread it, 920 or whatever. So basically the data itself is simulated, meaning the stack which is running in the respective ECU simulating this data, and gateway sends the diagnostic command to receive the response to display it here. So I can also click read all to read all the parameters, and also you have one specific software version which is like version 5, which is flashed and running in this particular Zephyr element. And also you can do the same exact thing with NuttX RTOS as well. In this case, I can go and say what is the engine speed, coolant temperature, and I can also say read all and see a different version of software which is running in NuttX. So I will come back to Zephyr again, and then we now are able to read all our diagnostic parameters over the UDS stack, which speaks over CAN right now, and also have certain test or self-test routines where I can run and see certain results to see if the CAN communication and various commands is functional between the gateway and as well as the ECU. And then the last one here is command, which you can send it by manually editing it, meaning using the console interface, you can send an explicit command over UDS, and you can get the raw response from the CAN, and it is displayed right here where you can manually decode it. In certain cases, you have vendor specific UDS commands to use. That's about the interface. And you have one additional portion, which is, as I said, about over the air update. I'm going to select, maybe we can, before going selection, you can say what is the current version. Basically it is 5. I will choose some other version, maybe version 2, and then give start update. Right now it's updating, meaning from gateway to this device over CAN using the UDS command to update 30, that is the command which is 36. So right now you can see the progress of the update happens over CAN. It would take a while, and once the update is complete, the new software would be rebooted into, and then you have a newer version coming into place. So the whole thing on the stack, which I explained in the other slide about MCUboot having 2 different partitions, keeping A and B copy, and then that's what it's happening. The second image is going to flash in the partition B, and then it would be rebooted. Before, in the same time, while the update is happening, we can switch back to NuttX interface, and you can do the same exact thing between switching the versions and see what is the current version ongoing flashed into this device, so on and so forth. But there is one additional element which I would like to show with respect to the NuttX, because NuttX also has this Ethernet connected, and you can switch between CAN and Ethernet. As you see, ECU is offline with respect to Ethernet. This is because we didn't set up the Ethernet network interface for that particular device. So what I need to do is I need to set the IP address. The gateway which sits here speaks over the IP address .100. Maybe I should also set similar subnet IP address in this case. So I would choose 123 and then say apply this interface. That means the NuttX is now up with this particular IP address, which is also displayed here. Now I can also try a ping between communicating between the gateway and as well as the NuttX. So now we can see the ping is successful and the communication by itself is successful. So what I could do now, switch to Ethernet instead of CAN. That is going to work over DoIP, that is the UDS stack over IP interfaces, and I can do the same exact thing, meaning reading the UDS interface diagnostic information over wait a second. There was a glitch in the setup. So otherwise you can read the diagnostic information over Ethernet or CAN accordingly. So same thing you can repeat with hard-coded commands or whatever the commands you can manually send. So, and this interface also gives set of other activities, for example resetting the hardware and so on. But then, like, we come back to the other ECU where the OTA was running, you can see the software update is complete. Now we can go and see what is the version of the software. So which is previously version 5, now it is version 2, which is like update over the UDS stack technically. So now we have interfaces to say how to configure it and then make it work and see how the diagnostic service works, but also there is another UI to display what's exactly happening in the whole setup. So this is the UDS stack which I've been explaining on the presentation and as well as in this demo. One, it can work over CAN bus or in TCP/IP, which is on the Ethernet. So it follows ISO 13400 or the other one on the CAN, ISO-TP. So all of them is implemented, and then you have the custom UDS application which is built and running in both Zephyr cases and as well as the NuttX case. So one other thing which I wanted to pinpoint here is both NuttX and Zephyr is connected over the diagnostic tester, which is currently connected over CAN. So for if I switch to NuttX and switch to Ethernet, then you would see the communication itself switches back from CAN to Ethernet in this physical connection. That's in a nutshell. You can repeat the same testing between NuttX and as well as Zephyr accordingly, and then you can do OTA, diagnostic and all of it. So that's in a nutshell overall demonstration. Thank you so much. Otherwise, if you have any questions, please feel free to write to us, contact@linumiz.com.